Hello and welcome to our 8th video on angles. I'm Mr. Chowdhury and today we're going to be looking at alternate angles. Now if you haven't already, I suggest you go and watch our other videos on angle facts, and if you've watched those you can come back to this one. So your first task is to draw a set of parallel lines and a transversal. Now just to remind you what a transversal is a straight line that passes through at least two other lines. A transversal is a straight line that passes through at least two other lines, and then you're going to measure the following angles. So here's my diagram. There in black are my parallel lines, in purple is my transversal, and the two red angles are the ones I'm going to measure. So pause the video and have a measure. Okay, just to help you out, here's my diagram, and I measured both of my angles as 40 degrees. So because I've only done one diagram, I can't really notice something, so I'm going to draw another diagram and I'm going to measure the other two. So I measured the other two angles and I got 140 and 140. So in my first diagram I got 40 degrees and 40 degrees. In my second diagram I got 140 and 140. I'm starting to see a pattern now, so maybe do a couple more and see what you get. So here's another one that I did and I got A and B. Pause the video, have another go. What do you think is going to happen if you measure those two angles? Okay, so you should have had a measure of those and you should have noticed the following thing. So if I've got a diagram that looks like this, and I've got A and B as my angles I'm measuring, then I should notice that A is equal to B. In my first diagram, I had both my angles being 40 degrees. In my second, I had both my angles being 140. So then I know that A and B are going to be the same. And that's because of this wonderful angle fact, which are that alternate angles are equal. Now here's a new keyword that you haven't seen before, the word alternate. What makes an angle alternate? Well, angles are alternate when they have the following characteristics. They need to have all three of these characteristics. So characteristic one is that the lines are parallel. So I can see my two black lines are parallel, and that's denoted by this arrow. The second one is that both angles are on opposite sides of the transversal. So I can see A is to the right of the transversal and B is to the left of the transversal. And my last one are both angles are interior to the parallel line. So I can see that they are both inside the parallel lines. If they have all three of these characteristics, then the angles are alternate and they are also equal. I'll read them out again for you. So the lines need to be parallel, the angles need to be on opposite sides of the transversal, and both angles need to be interior to the parallel lines. So let's have a look at this diagram. Are the angles equal? Are the angles equal? Pause the video, have a think. Are the angles equal? Now if you said the angles are equal, you are correct, and we can go through our characteristics just to make sure. Do we have a set of parallel lines? Well, yes we do. The black lines are parallel because of our arrows. We know that they are parallel. Are the angles on opposite sides of the transversal? Well, they are. I can see my transversal is in purple. The pink angle is on one side and the blue angle is on the other side. So I know that they are on opposite sides of the transversal. And the last one is, are they interior to the parallel lines? And they are. They're both inside the parallel lines. So we can say that these two angles are the same because they are alternate. Pause the video. What about now? Are the angles equal? Now, if you said no, you are correct. If you think about the first characteristics, the number one characteristic is that the lines need to be parallel. Although these lines look parallel, because we're not given the arrows to say that they are parallel, we can't assume that they are parallel. So then, if they're not parallel, these angles are not alternate, and therefore we cannot say they are equal. However, if we measured them and they are equal, then we can say that the lines are parallel because the alternate angles are equal. Right? So let's have a look at this one. Are the angles equal? Well, no, the angles aren't equal because we can see that they're on a straight line and they sum to 180. But also we can check to see which of the characteristics they fit. Well, it looks like they fit all the characteristics. They're on parallel lines, they're on opposite sides of the transversal, and they are interior to the parallel lines. You can see very clearly that they aren't equal because they're on a straight line. They are both on the same line. We have to remember that they need to be on opposite lines. Right? One more. Are they equal? Well, we can say that they aren't equal on this because of the following fact. I know that this blue angle is outside of my parallel lines. So it does not fit the third characteristics. So they are on parallel lines, they're on opposite sides of the transversal, but they are not interior. That's one way we could look at it. But also we could look at the following thing. I know this blue angle is given to us. Whatever it is, it doesn't really matter. This red angle must be equal to the blue one because they are opposite. And then we can say, well, the red angle and the pink angle are co-interior, which is one of our angle rules we learned earlier, and co-interior angles are not equal. Co-interior angles sum to 180. The only way that the blue angle and the pink angle would be the same is if they were both 90 degrees. So hopefully that's helped you understand what alternate angles are. What I suggest is that you go and watch Mr. Amison's video and practice doing some questions. If you're feeling super confident, you can go on Dr. Frost and Corbett Maths and practice some questions on there. Hopefully this has been helpful. Go off and be productive, and I'll see you in the next video.